As you see written here, we are working on our fifth construction. We have a line here with 2 points on it, and what we want to do is draw a perpendicular line, so a line perpendicular to this one that goes through a point on a line. So before we did perpendicular bisectors, so you take like the segment CD and you draw a perpendicular bisector, so a line that's perpendicular through the middle here. Now we want to draw a line that's perpendicular just through point C or just through point D. I'm going to do both of those. We'll start with C, draw a perpendicular line right through the point C, and then we'll do it again so that hopefully you'll catch it by the time we get to point D. Alright, so again, we're doing this with a compass and a ruler, a compass and a straight edge. Just like before, you're just going to pick some arbitrary length, and by arbitrary I mean random. It doesn't matter what it is. You're going to put your point right in C, so that's going to be kind of your center of your circle. You're going to strike an arc onto your segment on both sides of CD, or both sides of C, I'm sorry. So really what we've done here is we've said this is the center of my circle, and you've created a radius length here and a radius length here. So C is the midpoint between these two intersection points. So if you think back to the construction 4 where we did drawing perpendicular bisectors, now if we use that method and these 2 points, we're going to end up drawing a line perpendicular right through C that bisects this segment right here. If I called that segment, I'll call it XY. If we draw the perpendicular bisector of XY, it's going to go right through C because C is our midpoint. So if you remember how to do that construction, make sure you have a length that's a little over halfway, and you're going to strike an arc, or at least over halfway. It doesn't have to be just a little, it can be over. Strike an arc above. Now you could go below too, like this, like you did before, but you don't have to, and I'll show you why. And then you go over to Y and you do the same thing over at Y. And then you could do it below too if you want, not necessary. And this is the reason it's not necessary. If we know that this is going to be a point that's on the midpoint or above the midpoint of this segment right here, then we don't need another point because between any 2 points there exists one line. So if we use these 2 intersection points, you should get one line going through there, but as you can see it also goes right through C. So if we just had this top line and we went through the top intersection and point C, then we'll get that same exact line. So this line right here is perpendicular to our original line through the point C. So now let's do the same thing over at D. Do the same basic idea at D. So pick some length, doesn't matter what the length is. Those are going to be our 2 intersection points, and note that we're doing this intersection and this one, not the Y point. So now you're going to take your compass again, make it a little bit bigger than halfway, draw an arc above D from one side and then above D from the other. So now I've created an intersection point above D. Now when we draw the line through that intersection and point D, that should give us the line perpendicular to this line through point D. So we've drawn 2 different perpendicular lines. And again, you can always check with your protractor to see if it measures up. So if we look here, if I measure up my protractor, it looks like this is exactly on 90, so we did a good job with this one. Now how about this one? Just double checking. Kind of measure it up. This one was a little sloppier. And I think the reason it's a little bit off, just probably a fraction of a degree or 1 degree, is because my point is so large. I went through probably the right side of the point rather than the center. So that's probably the only thing that made the difference there. So that would be close enough. If you had that on a quiz or a test, you'd be more than fine. Alright, with that said, what I want to do now is I want to construct a square. So let's say we have a line segment here. I want to construct a square that has this length for all 4 sides. So you may be thinking, alright, how in the heck am I going to do that? Well, think of it this way. you're going to use construction 1 that deals with lengths of segments, and you're also going to use this construction here to draw perpendicular to a point on a line. So let's think about the properties of squares that we know. Squares have 4 right angles. They have 4 right angles, and they have all congruent sides. So it's a rhombus, and it's also a rectangle. So right now we have a line segment. We know that this is going to be the length of all 4 of our sides of our square. We also have the ability to draw a perpendicular to a point on a line. So if I want to draw a perpendicular to point A and point B, that's going to help us as we do our construction. So let's start by doing that. We're going to draw lines, perpendicular lines to points A and B. So in order to do that, we need to extend this out. So I'm going to make it dotted so it can separate it. If you're using pencil, it'd be nice because then you can just use a pencil line and make it really light and thin. But with a pen, it's a little more challenging to do that. So again, let's draw lines perpendicular to A and B. So we've got a segment here, a little arc there, a little arc there. I'm going to do the same thing over at B right away. So I'm going to try to go through this rather quickly. That intersection right there. I'm probably going to want to figure out where exactly that intersects the line. So draw a little segment there. Now I need to take my compass and go over halfway to figure out, alright, where are these arcs going to intersect? Should be the same over here. Just going to jump over. Now do it on the other side of A. The other side of B. So far so good. And I know I'm doing this rather quickly, but let's see here. Now when I draw the line through A, it's going to go up like that. B also is going to go up like that. So we've got segments going up that way, up toward the north or the top. So we know that these lines should be perpendicular to our original line AB. What we can do at this point is we don't have to do any more perpendicular lines. All we need to figure out is what is the length of AB. And the reason we only need to find the length of AB is this right here. If I know this is the length of AB, when I carry it up here, I'm going to draw an intersection somewhere up in here. And I can do the same thing over from point B. So we're going to have some sort of intersection up here from our perpendicular lines. So my original lines weren't quite long enough. But where these perpendicular lines intersect that arc that represents the length of AB, that's going to be a side of my square. So you've got this segment going up like this. They intersect there. So this point right here and this point right there are going to be the other 2 corners of my square. So once we connect those 2 points, what we have just created here should be a square. This side should be the same length as this one should be the same length as that one, and you should have 90-degree angles at all 4 corners. So let's figure out if we indeed do. That one looks pretty good. That one looks pretty good. If we measure this one up, that one's looking pretty good. So this one should also measure up pretty well. Pretty solid. So we've created 90-degree angles here, and all of our lengths should be the same. And the way we can check is, alright, that compass length is the same as this one, so the radial distance is the same if I don't change my compass length. So you can see this length is the same as this length too. So we indeed have created a square with side lengths equal to AB.